Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to go over how to balance chemical equations, and I'm going to go through some practice problems. So let's get into this. So when you're balancing chemical equations, there's a couple of different ways you could do it. One way is to balance each element at a time in a certain way. So the way that I'm going to show most of the time is you always balance your metals first before you balance your non-metals. So if you've got metals, balance those first and then balance your non-metals. After you've balanced your metals, then now you're going to balance your non-metals. You want to balance everything that except for hydrogen and oxygen. So if you've got nitrogen or sulfur or anything like that, you're going to balance those first before you balance hydrogen and oxygen. You're going to leave hydrogen and oxygen for last. And then out of those two, normally you're going to leave oxygen for last and balance hydrogen before oxygen, but that's not always the case. This is kind of a general rule or a rule of thumb, right? So the other thing you want to keep in mind is, like, if you have a pure element by itself as not part of a compound, normally you're going to leave that to last. So whatever that element is, if it's oxygen, nitrogen, or whatever, you're going to leave that to last and balance everything else before you get to that one. And then when you balance the last element, especially if it's an element that is by itself, look to balance with a fraction. You don't have to balance with a fraction all the time, but in some cases, balancing with a fraction will be helpful, because then you can get rid of the fraction by multiplying by a factor. So if I have to use a half of a molecule, I'll go ahead and use a half of a molecule as long as I can get my equation to balance, and then I'll multiply the whole equation by 2 to get rid of that half, and yet still keep the balanced equation. So that's one way to do it. The other way to balance an equation is you could use the subscript of the element in its elemental form as the coefficient of the compound, and then you could use the coefficient of the same element in the compound and write it as a coefficient for the element. That would be one way to do it, and then you can go from there in balancing your elements. So I'll show both of those along the way. So let's get started on number one. So on number one, we have NH3 gas. This is ammonia gas reacting with oxygen gas to give you N2O, dinitrogen oxide, and water. So we don't have any metals, so we don't have to worry about that. And so we're going to go on to the nonmetals. Notice we have nitrogen, oxygen, and hydrogen. So we'll balance nitrogen first. So I have 2 nitrogens here. 1 coefficient times 2 gives me 2. And then here I have 1 nitrogen. So whenever you're balancing chemical equations, you are never going to change subscripts. Okay, so pay attention to Taylor Swift. You are never, ever going to change subscripts of your formulas. You are going to only work with and change the coefficients. So if I have 1 nitrogen here and I have 2 here, then I'm going to need a coefficient that I multiply by 1 to get the number I want, right? So I need 2 over here. So what times 1 gives me 2? 2. So I'm going to put a 2 coefficient. So what am I multiplying? I am multiplying the coefficient by the subscript to get the number that I need, right? And so for this one, there's no subscript, but it's a 1. We don't write 1s, right? Just like coefficients, there's a 1 here, but we don't write 1s, right? So that's what I'm doing. So I'm multiplying the coefficient by the subscript to get the number that I want. Okay, so I have 2 nitrogens here. 2 times 1 is 2. 1 times 2 is 2. I have 2 nitrogens, so that's balanced. Okay, now I'm going to go to hydrogen. Notice that I have oxygen by itself. So because I have oxygen as an element by itself, I'm going to save that to last. And so I'm going to go to hydrogen. So here I have 3 as a subscript. So 2 times 3 gives me 6. So over here I have a subscript 2. So what times 2 is going to give me 6? 3. So I'm going to write a coefficient 3. So 3 times 2 is 6. 2 times 3 is 6. So now my hydrogens are balanced. And you'll notice that my nitrogens are still balanced. So nothing's changed there. Now I have oxygen, that's last. So now I need to balance the oxygens. So here I have 2 oxygens. And here I have 1 oxygen. 1 times 1 is 1. So I have 1 here. Plus, and here I have 3 times 1 is 3. So I add that together and I get a total of 4 oxygens. So that means I need a total of 4 oxygens over here. So what times 2 gives me 4? 2. So I'm going to write a 2 coefficient. So in this case, I didn't have to have a fraction to balance my oxygen. Sometimes you will. But in this case, I didn't need a fraction. I need a whole number, it works fine. So you'll notice that all of the elements are balanced. So you can always double check after you're done. So 2 times 1 is 2. 1 times 2 is 2 nitrogens. 2 times 3 is 6 hydrogens. 3 times 2 is 6 hydrogens. And 2 times 2 is 4 oxygens. 1 plus 3 times 1 is 3 equals 4. So everything is balanced, so this is our balanced equation. Okay, next, number 2. Again, we have nitrogen, hydrogen, oxygen. That's it for this one. Now, in this case, we have nitrogen that is an element by itself. So we're going to save nitrogen for last instead of oxygen. So again, whatever element I have left or by itself as an element, not part of a compound, I'm going to save that for last. So in this case, it was oxygen, so I saved oxygen for last. In this case, it was nitrogen. Normally would leave oxygen for last, but in this case, nitrogen would be the better one. Okay, so I'm going to balance oxygen first. So in this case, I can balance either one, it doesn't matter. So let's say hydrogen. So if I balance hydrogen, I have 4 here. 1 times 4 is 4, so I have 4 hydrogens. Over here, I have 1 times 2. I only have 2 hydrogens over here, so what times 2 gives me 4? 2. So now my hydrogens are balanced. So I have 2 over here, and I have 2 over here. Or so 2, where is it? 4 over here. So 2 times 2 is 4, and then 1 times 4 is 4 over here. Okay, so now let's try the hydrogens. Oh, I'm sorry, the oxygens, my bad. So here I have 4 oxygens, and here I have only 2 oxygens. So I need 4 oxygens over here. So if I change that to 4, right? So 4 times 1 is going to give me 4. Now I have 4 oxygens, and then I have 4 oxygens over here, but my hydrogens are off by 8 or by 4. So I have 8. 4 times 2 is 8. I have 8 hydrogens here, but now I have 4 here. So I need to put a coefficient here. So what times 4 gives me 8? 2. So now I have 2 times 4, 8 hydrogens over here. 4 times 2, 8 hydrogens over here. 4 times 1 for the oxygens, 4 oxygens. 1 times 4, 4 oxygens. So now my oxygens and nitrogens are balanced. or my oxygen and hydrogen is balanced. And sometimes you might have to go back and forth a little bit to get the right balance. So now that we've got these two balanced, now I have nitrogen. So now I want to balance nitrogen. So over here I have 2 times 2 is 4. I have 4 nitrogens here. I have 1 times 2 nitrogens, and then add that together. I have 6 total nitrogens on this side. And over here I have 2. So I want 6 on this side. So what times 2 gives me 6? 3. And there you go. And again, you can double check. You have 4 here. You have 2 there. That's 6. 3 times 2 is 6. That's balanced. You have 2 times 4 hydrogen. That's 8 hydrogen. Plus 4 times 2. That's 8 hydrogen. And then you have 1 times 4 oxygen. So 4 oxygen on this side. 4 times 1, you got 4 oxygen. So everything's balanced. There you go. Okay, let's go to number 3. So this is where the balancing in this way, you could probably do it, but it's going to be a little tricky because both of these are by themselves and they both form this compound there. What you'll notice here is that the phosphorus and the phosphorus both have 4, so that's already balanced. So you're going to have to balance the sulfur. And this is where I was saying where you can take the subscript of the element on this side and place it as a coefficient of the compound with that element on this side. So I can take this 8 and write that as a coefficient there. And then I can take the subscript of the element here and write that as a coefficient on this side. That way I know I'm balancing this here because in both cases it's going to be 3 times 8. So 3 times 8 gives me 24. That's 24 sulfur on this side. 8 times 3 gives me 24. So I balanced the sulfur. But now I have to go back to my P4 here and balance that since that's off. But notice that 8 times P4 here, 8 times 4 gives me 32 here. So I can just put 8 here because 8 times 4 is 32. And there you go. I have my balanced equation. Let's go to number 4. All right, number 4, we have metals. Notice that we have a metal and we have a non-metal, right? We only have both of these are elements by themselves. And remember what I said, if you have an element by yourself, you save it to last. Well, they're both elements by themselves. So I would save oxygen for last. Do the metal first, right? Go back to the rule number 1. Do your metals before non-metals. So here I would do aluminum. So here I have 2 aluminum. What times 1 gives me 2? Well, 2. 2 times 1 gives me 2. So I have 2 aluminums here, 2 aluminums there. So that's balanced. Now I can do the oxygen. So notice that I have 3 oxygens on this side, but I have 2. I can still ask the question, what times 2 is going to give me 3? And here's where you can use a fraction. So here, I know that 3 halves, right, or 1.5, right? You could use either one. You could do 3 halves, right? You could do 3 halves or 1.5. 1.5 times 2 is equal to 3. So 1 times 3 is 3. 1.5 times 2 is 3. So my oxygens are balanced. So now I have aluminum is balanced, oxygen is balanced. This is technically balanced because 1.5 times 2 is indeed 3, and that balances with 3 here. However, when we write our balanced equations, we don't like fractions as coefficients. So we need to get rid of the fraction, but keep the equation balanced. And the way to do that is to get rid of the fraction here by multiplying by the factor of 2 because we have 2 on the bottom of our fraction here. So if we multiply by 2 here, we need to multiply by 2 everywhere to keep it balanced. So we have a 2 here. 2 times 2 is 4. So we're going to change that to 4. Here we have 1.5 times 2, or 3 halves times 2 gives us 3. So we're going to put a 3 here. And then 1 times 2 is 2. So we're going to put a 2 there. And then we can check to make sure everything's balanced. So 4 aluminum, 4 times 1 aluminum, 2 times 2 is 4 aluminum. And then we have 3 times 2 is 6 oxygen, and we have 2 times 3 is 6 oxygen. So this is balanced. That's how it's done. Last but not least, here we have some ionic compounds. We have polyatomic ions. So remember, when you're dealing with polyatomic ions and the polyatomic ions stay together on the reactants and product side, then you could treat the polyatomic ion as one unit. You don't have to count each and every atom in the polyatomic ion to make sure it balances. This will simplify the balancing process. So again, we'll balance our metals first. So here I have zinc. And so notice that I don't have any element by itself. So in that case, we'll balance the ions as whole. So the metal ions and the polyatomic ions. And so here the metals are first. So I have 1 zinc here and I have 3 zincs there because 1 times 3 is 3. So what times 1 is going to give me 3? That's going to be 3. So I have 3 zincs now. So the zincs are balanced. Now for the sodium, that's a metal. So I have 3 sodiums here. 1 times 3 is 3. And then what times 1 is going to give me 3? Again, 3. Okay, so now my sodiums are balanced. So now we can go to the nonmetals or the polyatomic ions. And here I have nitrate. So I have 3 times 2 nitrates. So that's 6 nitrates here. And then over here, I have 3 times 1 nitrate. Don't multiply by that 3 because that 3 is part of the coefficient. That 3 is part of the formula for nitrate. So don't say 3 times 3 gives you 9. Don't do that. So this 1 nitrate here, that's 1. And so 3, that means I have 3 here. So I'm going to have to change this to a 6. So now I have 6 nitrates. 6 times 1 is 6. 3 times 2 is 6. So now my nitrates are balanced. But look, I got to go back to my sodium. I have 6 sodium here, and I have 3 here. So I'd have rebalanced my sodium. So here, 6 times 1 is 6. So what times 3 is going to give me 6? 2. So 2 times 3 is going to give me 6. So now I've rebalanced my sodiums. Everything is balanced so far. My zinc is balanced, my sodiums are balanced, and my nitrates are balanced. Now it's phosphate. Let's check out phosphate. So here I have 2 times 1. Again, don't multiply 2 times 4 because that 4 is part of the formula. It doesn't mean I have 4 phosphates. So 2 times 1 phosphate gives me 2. And then here I have 1 times 2 phosphates gives me 2. So the phosphates are balanced. So this equation is now balanced. And that, ladies and gentlemen, is how you balance your chemical equations. I hope this was helpful. If it was helpful, then please, by all means, like the video, share the video, hit that like button over there somewhere. Also, make sure you subscribe to my channel. And when you do, make sure you click the bell and the notification bell so that way you can be notified by my videos. Make sure you click all so you can be notified by all the videos I put out. And then finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have a topic you want me to cover, or if there's a question or a problem you want me to help you with, then please, by all means, let me know. I would love to do that for you. Thanks for joining me, and have a great day.